This is the first video in a series entitled Getting to Know 3DXpert. 3DXpert is an all-inclusive software for everything having to do with 3D metal printing. Highlights in this series will include finding the best way to orient the part for printing. We will look at numerous support structures and how they can be used in combination. We will consider analysis tools for printability and geometric structure. We will look at lattice structures and infill patterns for lightning. And we will see the power of 3DXpert for generating scans. Thank you for your interest in 3DXpert. Our presentation begins with importing part data. 3DXpert will allow you to work with STL files, but also it has the huge advantage of being able to work with CAD files, whether that be translators such as STEP, IGES, SAT, or even direct translators, such as that from ProE or CATIA. It will also support assemblies as well as individual components. At this point, we will use the wizard to begin a new printed project. Once inside the printing environment, we find on the left the tree that we will use to manage the printed objects, and on the right the guide, which has all the operations we need to perform. Let's begin first of all then by selecting the printer. Here we see different printers supported by 3DXpert. We can then select the build plate we wish to work with, as well as the particular material we're going to print the part out of. We are now ready to load the part that we wish to print, so we will go back to the guide. We will select the next item, which allows us to import or bring in the part that's already been translated. This part could have been translated as we showed through import or modeled directly within 3DXpert. We now choose if we wish to keep the current orientation of how the part was modeled, and then 3DXpert loads the part in center to the tray. We now need to consider how we're going to position the part for printing. 3DXpert offers tools for helping to find the optimal printing position. We may choose to orient the part based upon what would be the shortest print time, what would allow for more parts to be arranged on the tray, or what arrangement would require the fewest supports. Each of those categories has been determined, and by tipping the part around or selecting each of those, we can see exactly what that optimal condition would be. When you see red, that shows you an area that would require a support. So this last orientation shows what would require the least amount of supports needed. We can manually orient the part any way we see fit as well, by perhaps picking a face that will be parallel to the tray, centering it, and then saying how far we wish to have that part above the tray, as illustrated here. Next, we're going to consider shrinkage compensation. As we know, each layer of the printed part will shrink as it cools. So this allows us then to adjust for that shrinkage in the X and Y size of the part while maintaining its overall height in Z. This brings us to the numerous analysis tools built within 3DXpert. The first being to check the part's geometric integrity. Is it designed as it should be, or are there geometric flaws that we could find? Is the part manifold? Is it truly closed? Or are there open gaps that need to be fixed, such as ones that might prevent the part from printing correctly? Our next analysis tool is going to check for residual stress based upon part geometry. More can be said about simulating the stresses within 3DXpert, and that'll be discussed in yet a future video, a true simulation of the entire printed process. The results you're seeing here is a quick check, again just strictly based upon part geometry. So it'll find areas where it calculates residual stress as well as looking at possible distorted areas on boundaries, like you see illustrated here. Our next analysis tool is slicing analysis. It also is a quick check type of tool. It's not actually calculating slices that we will use in the printing process, but is showing us the things that it anticipates we might run into. Those particular situations are shown here on this chart, where we're looking at areas where we might see a heat build up because of the slicing, and also areas that have gone from a wide area to a much more narrow area, causing possible distortions. Our next analysis tool is a handy tool called Curvature Map. It helps to find the values of the different rounds as designed throughout the part. This is important to make sure that we have the radiuses we need for a good printing condition. It allows you to interrogate each individual radius based upon a range of colors and values that can be controlled by the user. And at every point, it allows for any particular part to be tagged to bring emphasis to that particular feature of the design. This information can then be shared with the customer or other engineers in PDF format. This brings us to the last tool that we're going to consider, that being our measurement tool. It is very useful for finding a linear distance across the part, for finding angles to faces or edges, as well as individual arcs and curves. It will also calculate overall properties such as the volume and the mass, the center of the part based upon a bounding box, its overall X, Y, and Z size, and all this information then can be output. Of course, it's very important to have this information for quoting the amount of material to be used. It can be output then as an Excel file or as a PDF. Thank you again for your interest in 3D Expert. Please look for more videos on this series, such as building supports, manipulating the part for printing, and also working with lattices and infill patterns.